Lale. Well, that's the way we say hello in chat. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit about conics. Now, children, in this lecture, we will be looking up what a conic is, how conics of different types have different equations, and how they look when traced out in the XY plane. Then I will also tell you a special method of finding out the type of conic that you're dealing with in a very easy way. After this, we will also be looking up a sum where I will actually make you people find out the conic that you're dealing with. Then we will also be finding out a constant very characteristic of a conic, that is its eccentricity. Now, children, before we get started, let us quickly have a look at this lovely place where I want you to imagine that we are having this class on conics. This is Aloba Arch, Enedi Plateau, Chad. This is a natural arch which is a geological rarity. It spans 77 meters and towers 120 meters. It looks more formidable in the backdrop of the mystic Sahara Desert dotted with acacia trees. Make sure to visit this fantastic place. Have a nice time here, but do remember to have uadai, the special sweet dish of this place, and also tell all the people of Chad that you get to meet Lale. In this note, children, I will say Lale, but this time it is to conics, as we're going to start off with conics by telling a hello to it. Now, let me first tell you what a conic is. Whenever we talk about a conic, it is actually a curve which has been got by a cutting plane, that is a plane which cuts across a double cone, one with two naps, right? I'm sure you must have seen that earlier in your books. So there is a double cone and there is a cutting plane which cuts through. As such, we get a curve, and there are different type of curves that we get, right? The type of curves that we're going to talk about will be known as conics, right? Now, these conics have a special characteristic, that is, they are at a specific distance from a point which is known as the focus. It's a fixed point, and they also have a specific distance from another line which is known as the directrix, and this is multiplied with a constant e which is known as the eccentricity. And that is the reason why every conic has an equation, fp is equal to e times of mod of mp, right? Now, children, like I told you, f here is the focus, the fixed point, right? Now, p is a point on the conic, right? And if we talk about this mp, this is actually the perpendicular drawn from the point on the conic to the directrix, right? So let's think about a point here. So we can talk about a point, let's say this be f, right? And say this be another point which is on the conic, and let's say here we have another line, right, which is the directrix. So when we talk about this distance, actually we'll be here talking about this equation now framed geometrically, something like this. This is fp. As I told you, this point is p, right? And then we'll be talking about another line, that is mp, which is the perpendicular distance of the point p, right, from the line which is the directrix. So this is to be followed in the equation of every conic, right? That is fp should be equal to e times of mod of mp. Remember here that if we talk about this e actually is the special constant in every conic's equation, that is the eccentricity. Now, children, if we talk about the eccentricity, then it has three values in accordance with the three type of conics that we have, right? The first conic that we talk about is a parabola. right? Then we talk about an ellipse, and then after that we talk about a hyperbola. So when you talk about an ellipse, a parabola first, then its eccentricity is 1. If you talk about an ellipse, its eccentricity is less than 1. And if you talk about a hyperbola, its eccentricity is greater than 1. Right? So this constant which was there in this equation, the eccentricity, is equal to 1 for a parabola, is less than 1 for an ellipse rather, and is greater than 1 for a hyperbola. Right? So I'll just quickly discuss all of these things all over again. When we talk about a conic is actually a curve which has been obtained by a cutting plane when it cuts across a double cone, one with two naps, right? And the equation which every conic follows, that is a parabola, an ellipse, or a hyperbola, is Fp is equal to E times of mod of Mp. Now F is a fixed point which is known as the focus, right? And there is another fixed line which is the directrix. Now the distance of the point P which is there on the conic from the fixed point is E times the distance the point on the conic has from the directrix. And remember, this distance that we are talking about is only the perpendicular distance, that is the shortest distance, right? So this is the general equation of any conic. Okay, now we talked about E, the eccentricity. This is actually a constant which is characteristic of every conic, and it differentiates the different type of conics that we have. Now if we talk about a parabola, then the eccentricity is 1. If we talk about an ellipse, then the eccentricity is less than 1. And if we talk about a hyperbola, then the eccentricity is greater than 1. Right? So this was all about the theoretical things. Now let's quickly look up how actually these conics look when they are traced. So let's say now that we have our x-axis and a y-axis. Say this be the y-axis, and let's say now that this be the x-axis. And now after this, let us now try to form a parabola. A parabola, children, when traced out, is going to look something like this. For that matter, this is a right hand parabola. Similarly, we also have a left hand parabola, right? We have an upward parabola, and we also have a downward parabola. It is not necessary that all these parabolas pass through the origin. They can pass through different points. This point, which actually in this case is the origin, is known as the vertex of the parabola, right? So not more about a parabola at this time. So this is what a parabola is. You know two things about it, that is eccentricity is 1, and then how when it is traced out it looks like. There can be 4 different types of parabolas. Now after this, children, we will next now be talking about an ellipse, right? And so if you talk about an ellipse is going to look something like this. Okay, this say will be what an ellipse will look like, and in the standard forms its center is actually at the origin, right? So the origin serves as a center of an ellipse, and this is moreover a little oval shaped, right? Do you remember what the earth's shape was known as? Yes, Samriddhi? Don't remember? It was geoid. Does anybody have another name for this? Yeah, it was oblate spheroid. That means it was flattened at the poles and it was bulging at the equator or at the sides, right? So this actually is a parabola when traced out, and you know another thing about this, that its eccentricity is less than 1. Now children, when we talk about a hyperbola looks a little different. It is like this, with a little distance again like this. So there are two parts to a hyperbola, right? One facing the right, the other facing the left, or probably one facing top up and one facing bottom down, right? For that matter, if you want an ellipse has another form, the vertical form, and it can be formed something like this, right? So this is what? This is an vertical ellipse. So these are all the different type of figures that we have. I'm sure you people must be thinking that this has become a lot dirty, but as they are with different colors, so I'm sure very easily you're able to differentiate, right? So we have an ellipse, we have a parabola, and lastly we had a hyperbola. In the hyperbola, the eccentricity is greater than 1. And like I've already told you people, the general equation which satisfies all of these three conics is Fp is equal to E times of mod of Mp. Remember, F here is the focal point, it's a fixed point, and the line directrix is also a fixed line. And then we tend to find out this distance of the point from the fixed line, multiply it with the eccentricity, and that should be equal to the distance of this point on the conic from the fixed point, the focus. Okay, now knowing all of this, I like to tell you people that when you talk about a parabola, right? Now what happens in a parabola? How does its equation get formed? So if we talk about a parabola, children, then its equation is x square is equal to 4ay when it's vertically upward, when it's vertically downward, minus sign comes here, or it can have an equation y square is equal to 4ax when it is horizontal. If it's right hand parabola, then this is its equation. If it's left hand parabola, then only a minus sign will come on the right hand side, right? So there's one thing that you can note. Can you find that, Samriddhi? Yes, one thing you found out was that this equation is quadratic in x and linear in y, or quadratic in y and linear in x. That means in both the variables x and y, it will not be quadratic together, or in both the variables x and y, it will not be linear together. In one, if it is quadratic, in the other, it will become linear, right? So this is characteristic to the equation of a parabola, and I'm sure you're able to relate this a little with physics, because if you talk about projectile motion, there also you proved that the trajectory of a projectile which is performing projectile motion is parabolic, and that you did by proving it to be quadratic in x and linear in y. Right? Okay, now children, after this we will next be talking about let's talk about an ellipse first. So when we talk about an ellipse has an equation which is x square upon a square plus y square upon b square is equal to 1. Okay, so this is the equation of one of the ellipses, and the other equation except this is y square upon a square plus x square upon b square is equal to 1. Samriddhi, were you able to make out something? Yeah, today the spotlight is on you. So can you find some difference here? No? I'll tell you. Look, here the denominator of x square is a square, and here the denominator of x square is b square. That means that a and b must be something special, right? So here children, remember that if we talk about the value of a is greater than b and b is greater than 0, or in other words we can say that a and b both are greater than 0 but a is greater than b, and there is a relation with the help of which you can get from a the value of b, and that is b square is equal to a square times of 1 minus e square, right? So this is the relation with the help of which you can get the value of b from the value of a and the eccentricity, right? Now children, after this, one thing more, if you talk about the first equation, you see that the denominator of x square is larger than the denominator of y square, and in this case it becomes a horizontal ellipse. And when you talk about this case, the denominator of x square is lesser in comparison to the denominator of y square, and this is when a vertical ellipse gets formed, right? After this children, next now we'll be talking about a hyperbola. Yeah, hyperbola word is there in English as well, but that has an entirely different meaning. Now here, when we talk about a hyperbola, the first thing that you got to remember is the value of e is greater than 1. That is, eccentricity is greater than 1. And here then, if we talk about the equation of the hyperbola, it looks something like this. It is x square upon a square minus y square upon b square is equal to 1, right? This is one of the equations, and the other equation is y square upon a square minus x square upon b square is equal to 1, right? So this is how we have the equation of the standard hyperbolas. Now if you talk about the first one, when the denominator of x when the denominator of x is such that it gives a positive sign to x square, then it will be a horizontal hyperbola. And if the denominator of x square is such that it gives this term with x square a minus sign, then this is a vertical hyperbola, right? So these are simple ways of checking out whether the hyperbola is horizontal or vertical. That is, if with x square you have positive sign, then it's a horizontal hyperbola along the x-axis, having its axis. Now if along the y-axis, if it's axis b, then it's a vertical hyperbola when the term with y square is positive, right? So these were few facts that we discussed about a parabola, an ellipse, and a hyperbola. We talked about their eccentricities. That is, eccentricity of a parabola is 1, right? Eccentricity of an ellipse is less than 1, and the eccentricity of a hyperbola is greater than 1. Then we talked about the equations, right? Here in a parabola, we discussed that there can be a right hand parabola, something like this, a left hand parabola. A right hand parabola has its equation as y square is equal to 4ax. A left hand parabola, y square is equal to minus 4ax. A vertically upward parabola has its equation like x square is equal to plus 4ay, and a downward parabola has its equation like x square is equal to minus 4ay. Then as its eccentricity is 1, so obviously the eccentricity e vanishes, as 1 is multiplicative identity. However, when you talk about the equation of an ellipse, it's x square upon a square plus y square upon b square is equal to 1. There we have the use of the eccentricity e, as we can find out the value of b from the value of a using the relation b square is equal to a square times of 1 minus e square. Now here children, you require to remember this, that if the value of a, b are talked about, they both are greater than 0. However, a is greater than b. Now if the denominator of x square is larger, then this will be a horizontal ellipse where its axis will be along the x-axis. And if the denominator of y square is larger, then it will be a vertical hyperbola, vertical ellipse, right? And its axis will be along the y-axis. Now next we talk about hyperbola whose eccentricity has already been discussed to be greater than 1. If we talk about its equations, if it's a horizontal hyperbola, then with x square there will be a positive sign, and if it's a vertical hyperbola, then with y square you will have a positive sign, right? In the first case, for a horizontal hyperbola, the equation will be x square upon a square minus y square upon b square is equal to 1. And for a vertical hyperbola, the equation will be y square upon a square minus x square upon b square is equal to 1. So you got to remember this, that with x square, if the sign is positive, then it will be a horizontal hyperbola. And with x square, if the sign is negative, then it will be a vertical hyperbola. Or you can even say this, that if the sign with y square is positive, then the hyperbola will be a vertical hyperbola, having its axis along the y-axis if it is in the standard form. Now here, children, I will also tell you the relation between a, b and e, and here you require to remember this, that if we talk about the value of a, b and e, we have b square to be equal to a square times of e square minus 1. Moreover, do remember that the value of e was greater than 1, right? So 1 minus e square would have given you a negative value, and then for b you would have got an imaginary value, right? So b square is equal to a square times of e square minus 1 is a relation relating b, a and e. And here you require to remember that the value of b can be lesser or greater than a. Alright, okay, now after you've learned all of these concepts, now let's quickly look about another concept that I was to tell you, that you can very easily find out what type of a conic it is. One thing you already know, that if it is quadratic in one and linear in the other, right, or vice versa, then you can easily say that it is the equation of a parabola. Very right, Samriddhi. Now if it's quadratic in x and quadratic in y, then what will you do? Because there are two equations that you have. So do remember that if you have equations of the conic to be such that they are quadratic in x and quadratic in y, then if both of them have the same sign, right, on one side of the equation, then you will say that it is the equation of an ellipse. Although the coefficients of x square and y square will be different, but their signs will be the same, then they will be the equation of an ellipse. However, if you have the equations of a hyperbola that you have to check for which type of a conic it is, then if the coefficient of x square and y square are opposite in sign, that means one is positive and the other is negative, then you can be sure that it is the equation of a hyperbola. Obviously the coefficients will also be different, right? So I told you three things here. The first is, if you have an equation which is quadratic in one variable and linear in the other, like x square is equal to 4ay or y square is equal to 4ax, then you will easily be able to understand that this is the equation of a parabola. If you have an equation which is quadratic in x and quadratic in y, then do remember that if the sign of x square and y square is the same when both the terms are on one side of the equation, when their coefficients are different, right, then you will say that it is that of an ellipse. Here I'd like to tell you one very important thing, that if you have the coefficients of x square and y square also to be the same along with the sign, then actually it is the equation of a circle, right? Do remember this. I'll tell you again. If the coefficient of x square and y square, that means the number which is multiplied with x square and y square along with the sign, is exactly the same when you keep both the terms on one side of the equation, then it is the equation of a circle. However, if the coefficients are different in numerical value but their signs are the same when the terms with x square and y square are kept on one side of the equation, then it's the equation of an ellipse. Similarly, when we talk about a hyperbola, you require to remember that if you keep the terms with x square and y square on one side of the equation, then if the coefficients are different, that means the numbers with which x square and y square are multiplied are different and their signs are also different, one is positive and the other is negative, then you will say that these are actually the equations of a hyperbola. Am I clear, Samriddhi? Sure? Okay. Now children, after this I have a question for you people. I like to tell you people that initially I'll give you a little time for trial, and after which I'll be discussing the question with you people. All those children who are studying offline, can take more time by pausing the lecture, right, and give it a bigger try, because all the things are now told, all the beans are now spilled, so making a curry out of it is going to be damn simple. Okay, think that you all have tried it well. Now I'll be discussing the sum with you people. You've been given here that find the eccentricity of the ellipse 4x square plus 9y square minus 8x minus 36y plus 4 is equal to 0. So here, children, what you do is, first we'll be talking about this equation, and we will try and settle this equation such that this becomes a proper quadratic equation by making them perfect squares of x and y. So here we have 4x square, which can be written as 2x whole square. Then we have the term with x, that is the linear term with x, that is minus 8x. Then we have plus 9y square, which can be written as 3y whole square, right? And then we have minus 36y, which is the linear term with y, and to that is 4 added, and we'll take the constant to the other side, make it minus 4 on the other side, as it was plus 4 this side. Next, now children, here what we can do is, like I told you, we can write this as 2x whole square, and the next term should be the 2ab term. As such, it should be plus 2 times of 2x, and that just makes it 4x, but we require minus 8x. That means the value of b should be minus 2, so that we can get to 2 into 2, 4 into 2 is 8, into x is 8x with a minus sign, right? And thus here we have got the value of b, the value of a being considered to be 2x. Now after this, next what we do is, now we get along with the term of y after dealing with the constants, as here we have minus 2 to be b, so we should be having plus b square, right? And then as we've written this extra, so we also have to subtract this and write minus times of minus 2 whole square. Then now we'll be dealing with y, so now we have plus 3y whole square, right? Then the 2ab term, so 2 times of 3y, the value of a, times of some b, so that we can get to minus 36y. So 3 to the 6, so obviously we require 6, so that has to be minus 6. So here thus we get the value of b to be minus 6 when the value of a is 3y, and thus we can now write this to be a plus b whole square after we've written the constants. So now this will become plus minus 6 whole square and minus 6 whole square, as this term minus 6 whole square has been written extra. That's why we are subtracting it also, so that both of these get cancelled and we get the whole thing back. However, we are going to draw a benefit out of this, and we will write this to be minus 4. And then in the next step, what we're going to do is, we will write the first 3 terms of this trinomial to be actually the perfect square of 2x minus 2. Right, Samriddhi? Understanding? Good. Now after this, we talk about the second term. The second term can be written as 3y minus 6, as we have the value of a and b, and we have a whole square of this, right? And then we have a minus 4, and we can also take these terms which were the constants with negative sign to the other side, so this becomes minus 4 here, taken to the other side will become plus 4, and this becomes minus 36 here, goes over to the other side to become plus 36, right? So plus 4 minus 4 gets cancelled, and you just get 36 in the right hand side. Now children, here you can do one thing, that is the coefficients of x and y can be taken outside. So here if you take 2 outside, then as it is going outer square, it will become 4. So you'll now have 4 outside, and inside you will have x minus 1, right? And then you also have a square of it. And similarly in the second bracket, when you take 3 to be outside, 3 square is going to become equal to 9, and then you'll have y minus 2 here, right? And then you also have a whole square of it, and that then becomes equal to 36. Now next what you do is, you can now put this in the denominator, so you will have x minus 1 whole square, and 4 upon 36 you will have, plus you will have 9 times of y minus 2 whole square, and in the denominator you have 36, and that becomes equal to 1. Now after this, children, next what you'll do is 4 will cancel 36 9 times and 9 will cancel 36 4 times. As such, this can be written as x minus 1 whole square upon 3 square plus y minus 2 whole square upon 2 square is equal to 1. Can you relate something? Relatable? Yeah, this is the equation of an ellipse, because this is quadratic in x, quadratic in y. The coefficients do vary, but the sign of x square and y square are exactly the same when they are on one side of the equation. As such, this does resemble the equation of an ellipse. But there's one thing more I require to tell you, that here you will say that if the center of the ellipse is some h comma k, then the equation of the ellipse is something like this. Yes, so what is it? It is x minus h whole square upon a square plus y minus k whole square upon b square is equal to 1, right? So here thus h comma k becomes the coordinates of the center, right? Like in this case, if you talk about the coordinates of the center, there'll be 1 comma 2, right? With that, then when an ellipse is drawn, as the denominator of x square is larger and the denominator of y square is lesser, thus you will say that this is an horizontal ellipse, right? If the denominator of x square would have been lesser and the denominator of y square would have been larger, then you would have said that this is a vertical ellipse, right? So this is how it is. Thus you've been able to find out what type of an ellipse this is. Now after you found out the value of a and b, now is the task of finding out the value of the eccentricity. So here, children, you will say that, excuse me, since, or rather you will say that comparing with above equation. Obviously you will have to write these statements, that's why I am writing this for you, right? We have the value of a, which has come to 3, and we get the value of b, which has come to 2. Am I right, Samriddhi? Right. So these are the values of a and b that we've got. Now after having this, we now have a relation that is between a, b and e. We discussed it just now, that is b square is equal to a square times of 1 minus e square. Now here, children, if you make e the subject of the equation, then e becomes equal to a times of, e becomes equal to root of 1 minus b square upon a square. So as we have these values, we can very easily calculate. So thus we will have it to be root of, yeah, obviously from this above equation that you have, b square is equal to a square times of 1 minus e square, you can easily get to this. I'll quickly show you. Look, here we have a square in the denominator, right? Now if you take an LCM, this will become a square minus b square, right? And then further you can take this a square to the other side of the equation, right? If we square both the sides, this will become a square e square, right? And then further here you have a square minus b square. Now if you take b square to this side of the equation and take a square e square to this side of the equation, you will get a square minus a square e square, and that is what is here, right? So from this equation we have got the value of e, and in this now we will be substituting the values of a and b that we already have got. So 1 minus 2 upon 3 whole square is what you've got. So this is going to become equal to 1 minus 4 upon 9. So that will then become equal to root of 9 minus 4, that is 5 upon 9 So the value of this is going to be less than 1, as you know that 5 upon 9 is a proper fraction, so obviously its root will also be less than 1. So this is then going to become equal to root 5 upon 3, which is less than 1, and that then becomes the value of eccentricity, which is what we had to find out in this question. So children, now I'll just quickly discuss this again with you. So here in this question, children, you had been given a equation which was a general equation, and you had to find out from this what type of ellipse this represents and what is the eccentricity. Right now, in order to do this, first what you did was you picked up this equation and you tried to make it a perfect square of x as well as y. Right, so this term 4x square and 8x are of the same type if you're to make a perfect square. Similarly, 9y square and 36y with a minus sign are also terms which can be coupled up and can help to make a perfect square of y. Then the constant has been taken to the other side so that all the constants can accumulate. Now 4x square can obviously be written as 2x whole square, right? And then we require the 2ab term, that should be plus 2 times of a is 2x. That means b has to be something such so that we can get to minus 8x, as now we've already got 4x, so we require minus 2 more. So that's why it will be minus 2, which is the value of b, and thus we now have to write plus b square, that is plus minus 2 square. Alright, and then as we've written this extra, we also have to subtract this. As such, we write minus times of minus 2 whole square. Now children, after this, next what we do is, as we have here this 9y square, it can be written as 3y whole square, and then the 2ab term is required, that is 2 times of a is 3y, b has to be such so that we can get to 36y with a minus sign, and as this is 3 to the 6y, so we require minus 6 more. As such, the value of b becomes equal to minus 6. Now that we have b to be minus 6, thus now we'll write plus b square, which is minus 6 whole square, and then we'll also subtract this as we've written this extra, so minus times of minus 6 whole square, and now we already have this minus 4 as a constant on the other side. Now children, next what we do is we can now write this trio to be the square of 2x minus 2, and we can take the other trio, that is this, to be 3y minus 6 whole square. Now after we've taken this, then the constants are left out with minus sign. We take them over to the other side. As such, minus 4 and plus 4 we have, which both get cancelled as they are identical but they share opposite signs. And after that, we take this minus 36 to the other side to make it plus 36. Alright, now children, after this we get to see that we have 36 on the other side, and we bring it over to the denominator of the left hand side. So we have 4 times of x minus 1 whole square divided by 36 plus 9 times of y minus 2 whole square divided by 36. Now how did we get these numbers 4 and 9 outside? That's by making the coefficient of x to be 1. Remember, in such sort of equations, when you have to find out what is the center or what type of a conic it is, you have to make sure that the coefficient of x and y is made to be 1. That is why when we take this 2 outside, it will be taken common from both these terms, and as it is going out of square, so it will also be squared. As such, it will become 2 square, that is 4. And here we can take this 3 to be common outside from both these terms. As it's a square, so 3 square, that is 9, will go outside. Now children, 4 cancels 36 9 times and 9 cancels 36 4 times. As such, this becomes x minus 1 whole square divided by 3 square, that is 9, and y minus 2 whole square by 4, that is 2 square, which is equal to 1. Now this can be compared with x minus h whole square upon a square plus y minus k whole square upon b square is equal to 1. So thus you get to see that h comma k is actually the center of the ellipse, and this represents the ellipse in the first standard form. That means it's a horizontal ellipse as the value of a is greater than b and a is underneath x square, right? So thus we can say that we have here an ellipse which is in the horizontal form, its center is at 1 comma 2, right? And after that, then we have been able to find out the value of a and b. That is, a is 3 and b is 2, because a is always greater than b, which is always greater than 0. So after getting the value of a and b, we can find out the value of e, as we have this relation b square is equal to a square times 1 minus e square, from which if you make e the subject of the equation, you will have e to be equal to root of 1 minus b square upon a square. Now children, when we calculate this, you can keep the value of b and you can keep the value of a, that is 2 upon 3, and square it. So thus this becomes equal to 4 upon 9. When you take an LCM, this will become equal to 9 to be the LCM, and 9 minus 4 will give you 5. And when you take a root of this, then this will become root 5 upon 3, which actually is the value of eccentricity. And you can say that this is less than 1, because 5 upon 9 is a proper fraction, and a proper fraction always has its value less than 1, right? And when you take out the square root, then too its value will be less than 1. As such, the eccentricity e is actually less than 1, which shows that this actually is an ellipse. Is everybody clear about this? Samriddhi? Sure? Okay children, so that was very nice going with you people to chat, doing that lale, and also learning all of these concepts about conics. I'm sure all of you people must have understood this, and if you have, then make sure to do another sum, which I'm going to give you in the description of this lecture. Moreover, if you have any doubts, there is a link to which you can click and tell me what the doubts are, or write a mail to me at themathematicshelpline@gmail.com. I'm sure to get back to you and help you out. So bye children, have a nice time, do study maths and practice it properly. Bye.